a discarded shipping pallet is built to withstand thousands of pounds of static load, not to become fine furniture. Today, one craftsman starts a transformation to bridge that gap. The initial breakdown requires careful, sustained leverage. Applying just enough force to defeat the ribbed fasteners is crucial. Using a steel rebar pin prevents the dry pine slats from splintering under the sudden release of pressure. Pine from these industrial crates is often case-hardened by years of weather exposure, making it unexpectedly resilient once it is properly resurfaced. It is a slow, methodical reclamation. Patience preserves the yield. Every intact slat recovered here dictates the scale of the final build. Once the rusted nails are pulled, the raw stock is ready to be dimensioned. Jointers and planers will strip away the weathered gray patina, exposing the bright, workable grain hidden beneath. With the milled boards glued and clamped into thick, solid blanks, the heavy crosscuts begin. Establishing a perfect 90-degree edge is the foundation of structural geometry. A high-tooth count miter saw blade shears through the laminated end grain without tearing the delicate pine fibers. Feeding the blade at a steady, controlled rate prevents the motor from bogging down and keeps the wood from burning. The resulting blocks are identical in length, ready to be joined into a specialized folding substructure. The notched center joint locks the two main supports into a rigid cross. This half-lap configuration maximizes the surface area for wood glue while keeping the entire profile perfectly flush. A single mechanical fastener is driven into the center of the intersection. It acts as an internal clamp, holding the joint tight while the adhesive fully cures. Deep structural slots are first established with the saw blade, creating the necessary clearance for the folding mechanism. A handheld router then follows up to refine the raw geometry. The rapidly spinning carbide bit easily chamfers the hard 90-degree edges of the pine. Breaking these sharp corners not only prevents splintering during daily use, but also significantly improves the tactile feel of the finished furniture. Precision is essential here, as any uneven routing will immediately telegraph through the final assembly. The tool is then carefully guided to mill a precise groove directly into the end grain. This deep channel will eventually house the articulating metal hardware, ensuring all moving parts sit seamlessly within the wooden frame. The outer subassemblies are finally brought together to form closed triangular supports. Triangles are inherently stable, geometric shapes designed to efficiently distribute downward weight across the entire footprint of the base. A generous application of yellow aliphatic resin glue absorbs deep into the porous, milled pine fibers. When the angled joints are pressed firmly together, the curing adhesive creates a permanent bond that is actually stronger than the surrounding wood itself. The cutting tolerances must be exact. Even a fraction of a millimeter of misalignment at these critical junctions would throw the entire folding base out of square. With the glued joints fully cured and sanded smooth, layout begins for the articulating hardware. Accurate marking is the first line of defense against a loose hinge. A Japanese pull saw cuts on the pull stroke, offering a remarkably thin curve and exceptional control when severing the cross-grain fibers. Once the perimeter of the notch is defined, a handheld plunge router clears the remaining waste material. Recessing metal hinges perfectly flush is a fundamental mark of professional cabinetry. It transfers the rotational stress away from the screws and directly into the shoulder of the wooden mortise. Depth control is critical here. If the routed mortise is too deep, the hinge will bind upon closing. If it is cut too shallow, an unsightly visible gap will remain between the joined sections. The resulting pocket must be uniformly flat. The steel plates are seated perfectly into their mortises and secured with mechanical fasteners. The torque of the cordless drill must be carefully modulated to avoid stripping the soft pine threads. Once the primary connections are established, the kinematic action of the base is tested. The structure easily transitions from a rigid, supportive footprint into a compact, flat profile. The precision of the earlier mortising ensures the folding motion is completely fluid, with no binding or resistance across the pivot points. Attention now shifts from the structural base to the complex decorative tabletop. The table saw is strictly configured to rip the remaining long pine stock into thin, highly uniform strips. Using a wooden push stick is an essential workshop practice. It keeps the operator's hands safely away from the exposed, rapidly spinning blade while simultaneously maintaining continuous downward and lateral pressure against the rip fence. This technique prevents the wood from chattering or kicking back, resulting in a perfectly straight, burn-free edge. Consistent width across every single strip is absolutely vital. Any minor variation here would eventually ruin the alignment of the geometric pattern. Once the linear ripping is complete, the miter saw is used to establish precise, identical angles on the ends of the strips. Processing these small components in a large batch ensures strict dimensional consistency. With the intricate herringbone glue-up fully cured into a massive rectangular slab, the true circular form must now be extracted. A simple wooden plank and a tape measure act as an improvised trammel arm. Pivoting from the exact center point, it guarantees a perfectly symmetrical radius across the uneven grain. This analog layout method is foolproof, ensuring the complex geometric lines intersect exactly where intended before the saw blade ever touches the wood. After the heavy bandsaw blade defines the outer rim, an orbital sander is deployed to refine the entire surface. Moving through progressively finer grits of abrasive paper levels, the disparate, glued pieces of the herringbone pattern into one continuous plane. The sander is also run along the curved perimeter, erasing the aggressive tool marks left by the bandsaw. This crucial step opens the wood pores, preparing the raw pine to accept a protective finish. The massive tabletop is deliberately split down the center seam, transforming a rigid wooden slab into a flexible system. Heavy-duty steel hinges are carefully positioned to bridge the two halves. The screws must bite deeply into the solid pine to withstand the constant torsional stress of opening and closing. Once the hardware is locked down, the mechanical concept is proven. The hinges allow the broad surface to effortlessly fold completely onto itself. This design solves the inherent spatial problem of large circular tables, creating a versatile piece of furniture that can be easily transported or stored away when not in active use. The complex folding substructure is finally mated to the underside of the completed table. Proper centering is critical for the balance and stability of the final piece. Long steel screws are driven at steep angles directly through the pine base. This technique aggressively pulls the mounting surface tight against the tabletop without piercing through the decorative face. The union between the geometric top and the articulated legs creates a cohesive, rigid structure. Every carefully milled joint and perfectly routed hinge now works in unison to support the load above. After a protective spray finish enriches the natural grain, the transformation is complete. What began as a pile of splintered, discarded industrial shipping pallets is now a highly functional piece of engineered furniture. The intricate herringbone geometry commands attention, while the hidden mechanics of the folding base provide quiet versatility. It is a testament to vision and exact measurement. Raw, forgotten materials, when guided by patience and precise tooling, always possess the potential for a second life.